All right, is everybody in camera view?
Should be.
Great.
Can we close the, we'll take both questions from the audience and also from, there's a bunch here.
May I just respond to your question?
Please, yeah, go ahead, Adele.
Thank you. Yeah, I just wanted to respond to Roger. I really enjoyed the comments, and I thought they were very insightful. And I just wanted to, I wanted to say that one thing we know about the kids' early overgeneralizations like da, is that if you can try this at home, but if you show your son a picture of yourself and a picture of a bike and ask him which is the da, he's probably going to choose you. So that, meaning that he doesn't have the word bike easily accessible, or maybe he can't articulate it yet. So he overgeneralizes, but in some sense he knows he knows that you're a better example of da. And I will say that you provided exactly the kind of indirect negative evidence that we do think kids learn from, because you paraphrased it and he didn't pick up on it in the moment, but that's going to happen again and again, where he's going to hear the bike referred to as bike and not as da, and eventually that'll become more accessible.
Great, thank you. First of all, I mean, I have to say my bike is a pretty good example of da, personally, I think, but I will test that at home. But does that mean more generally that you're on team children get more indirect negative feedback and learn from it than is typically viewed considered in the field?
That's right, and also that the kind of the error correction that the large language models get is actually appropriate, because as we're we do get the negative evidence that we're predicting the next word. Oh, it wasn't that word, right? And we might do that after the fact, where your son might say, he called it a bike, but or we could do it online. Yeah.
Cool, great. Okay, we have lots of great questions. Happy to take them from the audience. Tal, go ahead.
Yeah, okay, great. I had a question for Alex, but then also for other people, I think. So I really like the work where you show that you can decode a lot of the meaning of what the person think about from the brain using the transformer. And the application, I think, is very nice, and people who have aphasia will be able to express themselves. It's obviously useful technology if you can make it to work. But from the scientific perspective, I wanted to ask you what you think the interpretation of that result is, other than just that the information exists in the fMRI data. I mean, we obviously know that transformers can do a lot of things. Predict protein folding or whatever. We don't think that the brain can predict protein folding. Anyway, so what's the scientific interpretation of the results?
Yeah, so on the decoding side, mostly I think like the results that are scientifically interesting there are mostly the generalization results. Like, what can this generalize to? And that speaks to some kind of shared representation, or something is shared between them. In general, we think of encoding as the thing that tells us scientific things about the brain, and decoding is like a parlor trick that we do that's neat, but doesn't really tell us things about the brain. I think that's not fully true, but broadly true. That these encoding models, that how do we predict brain activity here? What does that mean to predict brain activity? What does that say about different parts of the brain and how they function and what kinds of things they represent? That's the much more scientifically interesting thing. In general, like I've been quite agnostic and quite publicly agnostic about whether this says anything specifically about how language models are like the brain, like mechanistically like the brain. I'm pretty skeptical of this broadly. I think they produce representations that can be mapped to brain activity, but that doesn't mean that those representations are arising in a brain-like fashion. It doesn't mean necessarily that the brain is predicting the next word, or that that's what it was trained on, because I think there's many ways that you can arrive at similar representations, even though that's a convenient way. So yeah, I guess maybe I'm more skeptical of that than others, but I hope that answers your question.
Great. So I'm going to move to answering a question that was posed from the online audience. Thank you all for the excellent questions. So this is from this question is when discussing the convergence of human language, human language behavior and large language model development, how can we augment or enhance large language models to effectively address tasks that surpass the formal and functional competences of humans? So for example, extremely long-range sequence-based tasks. I'll expand that question to say, is that a desirable thing for us to do? And if so, how would we go about doing it?
I will not answer the question directly, but I will latch on to the example given with the long context sequence, because I think that's one place where large language models diverge drastically from humans, with the current trend being increase in the context window, the number of tokens the models can take in, to, I don't know how much it is now, like 1 million, right? Like it's something ridiculous where, you know, a transformer has access to every single word of like a book that it's processing, and that's very clearly not how humans do it. And I think it's worthwhile to try and figure out other intermediate levels of abstraction that could be useful, where you throw away the exact token information, but you still have access to enough information to then be able to predict what's going to happen next, or do whatever task that you need to do, like summarize, etc. So I think, to me, there is a lot of potential. Like, this is a specific example where maybe there is potential to do things in a synergistic way for models to be more human-like.
But just
go
real
ahead.
quick,
Yeah,
at
sure.
the same
Yeah.
time, like the fact that humans don't do that doesn't mean that, from an engineering perspective, the fact that you can even process and have access to a whole book at once is incredible, and you can use it from a practical perspective to do very, very, very exciting things, even if humans cannot do that, right? I just, you know, like in defense of the of Mamba or whatever, you know, that's still super, super cool. Even, but yeah, for
Even if it works well.
yeah, sure, yeah, I don't know.
Yes, I just following on that, I think this is another place where I just read a paper recently about this, so it was on my mind, where another potential place for in long context and combining it with this like idea of reinforcement being important, but making that a slightly more active process, because I feel like the ways that humans probably do it is that you kind of remember like if you have a book and you've read the book, you kind of remember roughly which chapters might have had certain information. So you can kind of actively decide, okay, like maybe it's this chapter that's relevant. Maybe I'll go back and look at this chapter again, rather than, you know, just being able to look at the whole book at once. And so I think there was some, like being able to have, I think it's another opportunity for having different kinds of memory systems. Again, glomming onto the idea of like in context versus in weights being a different memory system, like having memory systems that have different levels of abstractions. Like if you can have something like a gist in your context, like each large chapter, you kind of summarize it into a gist, and what you're actually attending over are these gists and things like that, that you can have this hierarchical system of memory. I think that's another, like, not, I do think that these large, as Antonis pointed out, I do think that these large context windows permit a lot of interesting things, but I mean, it's kind of, I think, impossible to just attend to everything. So there will be some places where things are being dropped. So I do think that there's probably something to be gained for like allowing something slightly more hierarchical, or something that's a little bit more like human memory.
Can I just add? I think there are two objectives here. One is to build cognitive plausible models that we can use for humans and comparisons and, you know, modeling humans, and maybe do even like some clinical, like, you know, do stuff to the model that are not allowed to be done to humans. And then there's other objective, which is engineering. Do whatever you want, just as long as the model is amazing. And I think there, you know, if a human-like component is contributing to the performance, that's great. But I don't think there's any reason to build models more human-like. I think if anything, it's advantage to build them less human-like, so that they can do things that we don't.
Great. So I saw a couple of hands up in the room. Yeah, Tim, and I'm going to actually ask you to come up here if you're okay with it, and just speak your question into the mic, because we're having some requests to have the speakers in the room, or the questioners in the room, use mics. Here you go.
Thank you. This is really to anyone on the panel, although my question is inspired by learning about the EWOC database, which super interesting to me. I guess one thing that large language models can't do is act in the world and kind of experiment. I guess there are other kinds of models like the game playing models that kind of shook up the world in DeepMind that are doing that. They're generating outputs over some action space and able to observe through simulation of physical systems or Unreal Engine-like kinds of things, the consequences of their own actions. And through that, they can do something that seems kind of more like causal reasoning. And I'm just wondering whether people on the panel think that kind of a causal experimental acting in the world mechanism is needed to resolve some of the kinds of problems that the EWOC database was showing, right? Not like about, let's say, about spatial reasoning, but also any kind of causal reasoning there. I'll just add as a side note, there's a bunch of work in developmental psychology coming out of, for instance, Alison Gopnik's longstanding research program, suggesting that, kids are kind of born with a drive to experiment. And when you see your kid playing, they're really teaching themselves about the world by interacting with it and seeing what happens. And so I'm just curious whether language models are sufficient, or do we need something like that?
Thank you. I would actually venture to say that you might not have to act in the world, but you have to see it. You have to be able to imagine it. So the videos are going to be really important. But we know, blind people can understand all the language about vision and colors and understand all the associations. And I think, people who can't move for whatever reason can also learn the causal mechanisms as long as they can see and understand events. I don't think they have to actually experience them ourselves. I think our imagination is enough.
Yeah, and I think I think it's also interesting to decouple sort of two different things I think that happened with interactive learning. One is like interventions create a different kind of data that might not be available just observationally. And secondly, it's sort of like there's also so there are some things I think that might actually not be possible to learn, but it kind of but on the internet you might have people talking about having tried some of these things. So there's a possibility that maybe there isn't actually a data difference. That's kind of hard to evaluate. But I think the other difference is the data efficiency argument, that like most of the time that like children learn from active, or maybe at least models I think learn better from active from data that they've generated by actively interacting with the world, because they have some sort of hypothesis for what they expected to happen, and the feedback is more useful because they already knew what they were trying to learn when they tried that in some sense. So I feel like that's sort of more like there might not be a difference in the data observed. So the same exact data observed by a secondary person might not learn as much from it because there was no intent in generating that data. But I feel like and I think that the latter one, I feel more confident has been slightly taken care of by just the vast amount of data that we have. The data efficiency arguments are less important just because we have so much more of it.
And since the EWOC dataset was mentioned, we talked with some of the authors about causality as one of the concepts to test. And then we kind of realized that it's more of a second order concept because we have in the physical domain, we have concepts like collide and break, right? And then in order to probe causality, you would have to say, oh, A collided with B, A caused B to break. And so the cool thing about the dataset is that all of these concepts can then be combined into more complex scenarios to maybe get at some of those more complex nuanced relationships. So if anybody's interested in expanding that to causality, let me know.
Can I just say, I think it's exciting. I think there's kind of this result where any type of data contributes to the model, not just text, right? So if you add proteins, or if you add galaxies, or if you add like, embodiment or whatever, it seems to contribute to the performance. So any kind of so when there's structure to be discovered in the data, if you feed that to the model, maybe the model will be better. I think there are traces of that. And GPT-4 is allegedly a multimodal model. So I think that's a real potential. If that's true, right? If it's true that any kind of structured data that you feed the model will increase performance on other areas as well, that has huge potentials.
As has been touched on a few times, language reflects more than just language. It's like a reflection of our understanding in the world and our world knowledge. And I feel like, yeah, we're asking large language models to do a lot more than just language. And so, yeah, if we give them the ability to build their own model of the world, then their language skills are going to get better, as well as like they'll be able to like clean my car or whatever. But yeah, as we move towards AGI, like the more that the model is able to actually live a life more akin to human life, then the more it's going to be able to reason about more things, and that will be reflected in its language abilities.
So I'm going to merge two related questions that I think are complementary from the webinar audience. The first question is that multilingual models don't perform optimally across languages, and we have this problem of long-tailed distributions where we have a large amount of data from a few languages and very little to no data from most languages. And maybe that's part of it, and maybe there are additional issues involving training objectives and representation learning techniques. And so one part of the question is how can we help language models do better, learn better joint representations of languages, or maybe even just learn better individual models of language of all the languages that are used in the world, and can linguistics help with this? And then in a complementary direction, the second question is that do you see particular contributions of cross-linguistic analysis or multilinguality through LLMs that can actually help us inform our theories of language and linguistics?
I'll take some of that. So, okay, the first question, yes, languages, the data discrepancy is always going to be there. It's just that the way that we've been trying to deal with it has been very naive in the recent years. There's been a lot of work beforehand, and even work in English, where we introduced inductive biases into our architectures and into the way that we trained our models in order to deal with the lack of data that we suffered for decades before the last decade. And a lot of those came from linguistics or insights like that. So people did things like morphologically informed segmentation in order to better provide a little bit of intuition to the model how to deal with the input, right? But then when you have enough data, you don't need to do that. The model can just deal with whatever type of segmentation you choose, even arbitrary or random or whatever. So yeah, and then we still do this in my work, where we work with like endangered languages from the Americas or whatever. We still build smaller models and we put in those inductive biases to help them train and learn. And so a lot of the work is already there. It's just with the proliferation of LLMs and all of the exciting things that they can do, it's just kind of like stopped being relevant for a little bit, but it hopefully will come back again. And I don't remember the second part of the question.
Oh, the second part was, can we actually improve our understanding of like sort of theories of multilinguality through LLM techniques and models from a linguistic perspective?
Maybe, yeah. I don't know. Like, so the big thing, at least for a while, has been that it was very, very hard for a human, right, to digest all of the data that speakers produce and then come up with a theory that describes all of that mushy thing, right? And suddenly you can have a model that is a distillation of all of those speakers, or some of those speakers in a very interesting way. So yeah, you can definitely get insight. It's kind of like computational corpus-based stuff on steroids that I think is going to lead to very interesting results.
So I think, to me, large language models answer one big question, which is what is uniquely human about language, and what is the main specific, right? What kind of language specific things you have to assume to get the data, and what emerges in this general purpose cognitive thing that has nothing human in it. And I think from that perspective, if you observe a lot of processes in bilingualism in those bilingual models as well, right? So if the bird has accent, or if there's developmentally similar things happening, or if there's like L1, L2 phenomena, the first language, second language phenomena that are similar in these models, that means that there's some general, either pragmatic or just some general cognitive reasons for those properties, and we don't need to assume something specifically human. I think that's a big question. I mean, I think there's still an open question: is there anything that's specifically needed for human language? That's how I started. I'm not willing to say no yet, although the large language models have provided more and more evidence that there's little human specific or domain specific about language. Another thing I want to mention also as a really good potential, I come from Berkeley Linguistics Department, which has a very strong language revitalization aspect and language documentation. And there's languages out there that are highly endangered. And I think there's one big potential that I'm working with a few students as well, both on speech side and the text side, how to use this technology to help revitalize language or document language. And I think that's really exciting. I think there's a lot of work that needs to be done with the communities themselves. So you can just come with a technology into a community and say, this is what I want to do. It's like, it has to be very careful work with the communities. But I think for the communities that are willing to embrace that, I think that can represent a really optimistic tool for those tasks.
Yeah, Simon, come on up.
This is a funny, awkward thing. Okay, so thank you so much. This was really great. So I was really taken by Laura's point that it feels like one of the scientific bottlenecks here, maybe not the only one, but one of the big ones for LLMs to have a transformative impact on our understanding of language science is interpretability. And so that's a big scientific challenge, and whose scientific challenge is it? So is it something that we're waiting for computer scientists to solve so that we can use it? Or is there something that needs to be teams of scientists with all of these different types of expertise that are represented across this conference to be able to actually tackle what is maybe an intractable problem, but maybe something that we're actually going to be able to get a handle on?
I mean, it would be great if industry would take that on. I feel like that's only going to be the case if there is a sense that by interpreting these models, they can in some way make them better, or understand their failure modes. Maybe that's already a thing. But yeah, I feel like it's not just a goal of explaining everything in the large language model. It's specifically being able to explain the things that we're interested in, or hypothesize that it's going to be a candidate for how the human brain also solves things. So I feel like it's a subset of just explainability in general. And so therefore, I think it probably will fall under language or neuroscience scientists.
So I kind of disagree on this. I think we really need the computer scientists to develop things for us. I've been honestly pretty disappointed with sort of the application of neuroscience techniques to these models. I think we have gotten less understanding out of them than I would have hoped, given that we've been trying to study brains for a long time and thought we had a really good handle on a bunch of techniques, but it turns out they're just kind of okay at this thing. Whereas I think the techniques that people like David are developing are really exciting and really build on sort of deep, like mechanistic mathematical understanding of how the models work in the first place, which we kind of don't have for brains, and that's a problem for us. But yeah, so I think we need a lot of sort of cross contamination between fields to make this happen.
Yeah, I definitely agree. That's the future, is interdisciplinary work, where, it took me, I was trained as a linguist, took me another 20 years to become a psychologist, and I'll be dead before I become a computer scientist. So I think most of us need to collaborate.
I will agree with Alex that we need the synergy and people talking to one another, but I will, yeah, like I am not, I'm very optimistic about neuroscientists contributing to interpretability in ML and working together and vice versa, of course. I'm very excited about this. I think, first of all, the work I talked about about world knowledge is on the behavioral level. Like, here are tools that we use to study human behavior. Let's apply them to LLMs in a rigorous, controlled way. But we can do the same thing at the implementational level, looking inside those models and trying to figure out what are the representations and computations that enable those behaviors. And that is a problem that neuroscientists have been trying to study. So we don't have the answers. We don't know much about the brain works. We've made some progress for sure. But I think one thing we have is we started asking the right questions and making relevant distinctions and putting forth relevant frameworks. I am in an early middle collaboration stages with some neuro people and some interpretability people on a paper that tries to use more levels of analysis and use that framework to show similarities between studying the brain and studying artificial neural networks, knowing that we don't need to look at the circuit level implementation all the time. We can look at the higher level abstractions like representations, and then AI is kind of discovering it with representation engineering and whatever else. But there is lots of potential. And it goes both ways, right? There was this debate on probing, on decoding representations from different layers of a neural net that Ryan Cotterell and Adina Williams contributed to a few years back. And it's the same problem that we have when we try to decode stuff from different parts of the brain. Why are we using linear decoders? What happens if we make it more complex? What make it simple? What kind of information is informative? What kind of decoding can actually tell us about what that intelligent system is doing? So I think that crosstalk is super informative, and both sides can bring new insights.
And just,
sorry.
Just to add very quickly, I think linguistics and formalism can contribute there as well. And just in some ways, anthropomorphizing these models, as bad as it sounds, can help you, use approaches from various different fields to try to look inside them. And I think that's the answer. I don't think it's not industry, it's not a computer scientist. I think it's a plethora of approaches that we'll try that will eventually probably give us some insights.
I was just real quick add that I don't think that the interpretability performance trade-off is as dire as we make it out to be. Like, I don't think that the more interpreted models like convolutional nets or even other types of models are that much worse when given enough compute and data, or at least given our current architectures and the way that we have to train, hardware and the way that we train them, maybe they end up slightly worse. But I'm not entirely convinced that this trade-off is as, terrible. So.
Yeah, and just adding a very quick point, building on stuff that people have already said. One thing that I've realized is that while computer scientists certainly have much cleaner understanding of things like the architecture, like Alex mentioned, like things like, where you have the ability to understand where things are going, which may not be exactly the way that a neuroscientist comes to approaches the model. I think one of the things I've noticed is both from cognitive science and neuroscience, both of them are empirical sciences, and computer science historically hasn't been an empirical science. And so I think just this notion of hypothesis-driven exploration of like, this is what I think is happening, this is the experiment I'm going to design to test whether that's what's happening. I feel like that those are just traditions that don't like traditionally exist that much in an engineering field. So I feel like that's even at that extremely basic level, I think there's a lot that people from the natural sciences, from cognitive science and natural science and experiment design, making sure you can actually rely on the statistical relevance of your experiments. Like a lot of these things are fairly abstract. I think even those are very like useful things that people can bring to the table.
Sorry, I want to add one final point here. One thing that really doesn't help, and I think we'll all agree on this, is closed source models. That like really, really doesn't help. Yeah, let's have fewer of those, better open source models.
Great. I think we have time for one last question, and there's no possible better question than this one posed by an anonymous attendee. Panelists, how can the NSF better support linguistics work so that it can productively interface with you all? Let's try this. Maximum 3 sentences each. Let's see what happens in that. In any order.
That doesn't count as a sentence. I think collaborative grants, trying to bring together from the different disciplines that this workshop has represented. Great.
Thank you. Yes, I agree. And I would say the kind of linguistic work that interfaces with psychology and with computer science is the way to go.
All of that plus less budget cuts, I guess, or and like bigger projects, right? There's already interdisciplinary programs that, like the DLI that we've heard about before, but they also seem to have a narrow focus. So these bigger, more exciting things that we're talking about here need to be implemented, I guess.
And I just want to say, it's very easy to say more interdisciplinarity, but implementing that is very hard. And I think just maybe come up with some more structured ways to actually promote, somebody from non-traditional field entering another field or trying to collaborate with another field. I think in general, we all talk about how this interdisciplinarity is great, but when a proposal comes on the table, oh, this is questionable, or this is like not what I'm used to, and provide maybe more structured ways to address some of those concerns, because interdisciplinarity is hard. I mean, it's easier to stick within the discipline. So I think, yeah, I wanted to point out the difficulties that bring.
Yeah, and maybe tagging on to that, mediating the conversation between disciplines by having a way to for people to raise the needs or maybe the pain points, right? What the computer scientists need, what are they struggling with at the moment, what the policymakers need from researchers, right? So having a way to bring that information together such that people from the other discipline can be like, oh, I can contribute to that. Maybe I have some insights.
I'm going to second the call for big collaborative projects. I really love the CRCNS program that Ken over here is a big part of. I think a thing that's really missing here, though, is getting us to speak the same language. We have to agree on terms for things, agree on problems that are important, agree on ways of describing things. And I think that's one of the harder things to do between fields, and that's really important here. I don't know how to get the NSF to support that, but
is it a transformer block or a transformer layer, by the way? I want to know that.
Yeah, and I also think working with these large models is also like challenging, and it's a challenging engineering feat. Like even just getting even when a model is open source, like getting it up and running and setting up training or setting it up at the scale that like it's a lot of work. And so I think support even just with some of that, like I think some of these, like the ability to like share some of those resources in some way, share some of the know-how, or share some of the even just like instantiating these large models requires a huge number of compute chips. So like even if you're not training them. So I think finding if there are ways that people can share those resources in some way, I think that would be useful. And I think it requires somebody further up like the NSF to maybe help with figuring out how to share those resources.
Great. All right. Well, just on the last note of interdisciplinarity and connections, I did a little tally earlier today, and by my count, there are 15 linguists, 17 computer scientists, 11 psychologists, and 9 neuroscientists in this workshop. Now, if I add those up, I get 52, but there are only 25 participants in this workshop. And I think that speaks to the interdisciplinarity of all of you. And I want to just thank everybody once again for this participation. So this closes the morning of the second day. And we're now going to take a lunch break. And at 1:30, we're going to come back for a final set of summative talks and some brief closing remarks. Thanks a lot, everybody.